It would be really nice if we had like x to a power. We could do power rule. If it was just, like we've already talked about, if it was just a bunch of those separated by addition and subtraction, right? Yes? So like, if this was x plus 1 squared, couldn't you just like FOIL it out? Like multiply it out? You know what I'm saying or no? If the original problem was x times x plus 1 squared, then what I could do is I could square this first. I could do x plus 1 times x plus 1, and then do my little thingy here like this. And I would have that x sitting out there, and then when I do that, I would get x squared plus 2x plus 1. And then I would distribute the x through and get x cubed plus 2x squared plus x. So I pass that x through. And now I can do each one of these individually with the power rule. Does that make sense? So for this one, what I'd like for you to do is take x plus 1 times x plus 1 times x plus 1 and do that 900 times. And let's see if we can't do that in 12 minutes. No? That's what you would have to do though, right? If you're going to do it like this. And that doesn't seem sane, right? That doesn't seem like a sane approach. But at the same time, I'm not quite sure substitution does much either. Because what are you going to use for a substitution? I mean, do you see something in its derivative? All right. Who said yeah? What do you see?
I see that there's x, so I took the derivative of x plus 1.
Wait, do you want, okay. Are you telling me what you want u to be? Or are you telling me what the,
Yeah.
Okay, so what do you want, what are you thinking we could let u be?
X plus 1?
X plus 1. What's its derivative?
X.
No. What's derivative of x plus 1?
Oh, is
Just 1, right? And do you see 1 there? I mean, there's a 1, there's always a 1 there, isn't there? So that would work, right? I mean, that seems like it would work. But it's kind of like, is that even going to help? Let's see. Let's just see. This is another one where you have to take a swing, all right? Let's try to let u be x plus 1 and just see what happens. You ready? The derivative of this is 1. And if I multiply both sides by dx, I get dx. Okay. So let's play this little game. I will be able to replace x plus 1 right there with u, right? That's going to be u. And I will be able to replace dx right here with du. That's still good? What's the only thing we have not accounted for here? Like this is going to become a du, this is going to become u to the 900th, but what about the x? You never really dealt with that, did you? However, and this is the tricky part of this problem, however, look at this equation right here. You see that equation? Could you solve that equation for x? If I asked you, hey, take that equation, solve for x, what would you do? You just subtract 1 on both sides, right? Yes? So wouldn't this become u minus 1 is x? Yes? Yeah, right? So now I have something I can replace x with. And let's see what happens. Let's just go back in and replace everything, all right? So what does this x get replaced with? U minus 1. I'm going to put in parentheses. That's the x. What does this get replaced with? U raised to the 900th power. And what does dx get replaced with? Du. So you look at that now and you say to yourself, did I even accomplish anything here? Did we accomplish anything? Look at the difference between this and this and tell me if we accomplished anything with that substitution. Look carefully. What did I say in the beginning I wanted us to do in 12 minutes? If we wanted to do this with the power rule, we would have to do what? X plus 1 times itself 900 times? Do you have to do that with this one? You don't have to do that with this one. See? Because this is u to the 900th, right? This is something in parentheses. Can't I just multiply that through? Right? I can just do u to the 900th times u, which is really u to the what power? So I'm multiplying this through to here and here.
Is
U to the what?
901.
901. 901. Is that what you were going to say?
Yeah.
Yep, because the power goes up by 1. This is u to the first power, right? So if you do add one more u to the factors, you get 901 of them now. And then what's negative 1 times this? Just negative u to the 900th. And then du. Look at that. This is like x to a power, x to a power. They're separated by subtraction now. And you can do them individually. Pardon? What? Huh? Okay, well, let me just do it this way. X times x squared plus 1. If I asked you, well, let's do minus 1. If I asked you to multiply these, you do x times x squared, which would be x cubed, right? You're just adding one more to the power. That's what I'm doing here. U to the 900th times u is u to the 901, right? And then u to the 900 times negative 1 is just negative u to the 900. Good? What is the antiderivative of u to the 900 first power? You're supposed to add 1 to it, right? U to the 902, but you have to do something out front first. 1 over 902 u to the 902. That's the antiderivative of u to the 901. Minus, what is the antiderivative of u to the 900th? 1 over 901, right? 1 over 901. U to the 901 plus C. The only reason I use 900 up here is because I didn't want anyone to even think that in the beginning of the problem they could have just multiplied those together. Like if I would have done like x squared, you would have said, oh, I'm just going to expand it. By doing 900, I'm making you kind of submit to the idea you can't do that. Yes?
Would you be able to do just like dot minus that and just like bring out just a u? Or?
No, because the subtractant is not just u. Let me see if I can't convince you. Maybe, I think what you're suggesting is this. If you had like x squared minus x, is that equal to just x? I think that's what you're doing, right? To convince you that that wouldn't be true, just try a number. Try 5 squared minus 5. Is that equal to 5? Right? That's 25 minus 5. That's 20. So this doesn't work. The most you could ever do with something like this is factor an x out. Right? But you can't subtract. They're not like terms. Yeah?
It only does it with division when you subtract, right? Subtract.
If you have division, the powers then subtract. Yes. Pardon?
When they're stacked, you subtract.
Is that, yeah? I guess that's the way you could do it. Yeah. Am I done? You have to replace u with x plus 1. So this is going to be 1 over 902, x plus 1 to the 902, minus 1 over 901, x plus 1 to the 901, plus c. That's your antiderivative. So this problem was a little tricky, I think. But isn't that somewhat remarkable? How making a substitution that doesn't seem like it's going to do much of anything for you allows you to rewrite a problem where you would have had to expand something 900 times to a problem where all you had to do was distribute that through and then do power rule and you're there? That's a pretty powerful substitution we made there without even knowing it was going to turn out to be that good. Okay, yeah, I think that's it on time. So why don't you, on this homework assignment, let me just double check the homework assignment. This is for 13.2, 9 through 17, 25 through 33. So you can do everything except the last two problems, which were 79 and 80. Those are word problems. We'll get back, we'll do those next week. I'm going to do nothing but the applications next week. All right? But I'll see you on Thursday.